Okay, this is the session measuring urban sustainability based on resources. It's a CIB seminar on the 12th of the 12th in 2012. To discuss sustainability, it is relevant to understand what we mean with sustainability and non-sustainability and which resources are in place. Whether we should measure them or otherwise, we'll come back to that. And urban, for my point of view, is only a scale measure. So whether we're talking about a very low scale on a building level or on a city scale on an urban level, there's no much difference between sustainability. I have compiled a number of 10, 12 slides from a large presentation, which I often present. My name is Lescuere. I'm with Delft University of Technology, and my own company is Inspired Ambitions. It's a consultancy. The presentation is very much into energy and exergy, which is the quality of energy, or if you want, the difference between efficiency and effectiveness. And basically, it is also the difference between sustainability and cradle-to-cradle or cradle-to-cradle type of approaches. To understand sustainability, we have to appreciate the fact that in the UK language we have two possibilities. Either we talk about durability, something has a long lifetime or we have a lot of it, or the Brundtland type of approach, which we of course are referring to more often. And to understand that we are basically in a linear economy where we should run in circular economies, where a lot of recycling or upcycling is being done. I can recommend everybody to look to this small animation of 20 minutes, Story of Stuff, and it is very clearly showing the need to go to circular economy instead of a linear economy, or that a linear economy does not is not in place in an infinite planet. So if we have sustainability on one hand, we have also non-sustainability on the other hand. And what we are talking about non-sustainability, we're talking about natural resources. And here we mean the depletion of it and the consumption of it, the unwanted effects of the consumption. And what are the resources? There are four basic resources: energy, materials, water, and topsoil. I'll come back to topsoil in a moment. But at this moment, the effects of the depletion and the consumption are scarcity of the materials, of course, or the fossil fuels, health effects, biodiversity, the decrease of it, and climate change. If we talk about energy and we talk about fossil energy, we have had peak oil. As you can see over here, approximately in 2000, we had the peak oil production, and ever since it is decreasing. How long we are going to last, we are not totally sure, but it will never be as it was. And it has, in terms of consumption, of course, very nasty effects in terms of CO2, NOx, and SO2 and fine particles emissions. CO2 leading to climate change, NOx health effects, SO2 acid rain, and fine particles, yet again, health effects. Another issue in terms of scarcity is not the fossil fuels, but the materials. Here you see the estimated depletion of certain elements with an estimated 2% annual primary production growth, and it is incredible that within the next 20, 30 years there are already 15, 20 minerals which are, or elements which are depleted. It has not only a term of economy effect in terms of scarcity, It has also social consequences, as in a lot of cases the gathering of different minerals are really taking place in unwanted conditions. Yet another material is water. And water is extremely rare in this planet. You see a source from the US Geological Society showing the presence of water in the world. From all of the water in the world, there's only 2.5% fresh, and from that part there's only 1.3 available at the surface, and from that there's only 1/4 which is non-frozen. If you do the math, it's very simple. There is of every 1 million parts of water, there's only 87 ppm available for people as fresh water. And we are not very, we are using lots of it. So the question you could ask is, if you take a cup of coffee, how many cups of water are needed in order to produce this cup of coffee? And it's a very interesting site, and it shows that you need 1,100 cups of water in order to produce this 1 cup of coffee. It's waterfootprint.org. And of course, we are polluting the water in tremendous ways. Finally, we come to topsoil, whether it is desertification or deforestation. We have a lot of loss of topsoil, and the most interesting example is the Nazca lines in Peru, where used to be huge Huarango forests, which were taken into cultivation by the inhabitants, and after clearing it of the forest, the topsoil waded into the ocean or was taken away by rivers, and there's only bare rock left, and topsoil will not come back again. So how could you come to better situations in terms of energy, water, topsoil, or materials? You could, from a cradle-to-cradle approach, declare that you would only build buildings which produce more sustainable energy than the building needs itself, produce water cleaning equipment so that the water quality out is better than what comes in, that you produce more topsoil than is wasted in the building process, and in terms of materials, you have to close the biological and technological cycles to keep the materials in relation. So this leads within cradle to cradle to the difference between eco-efficiency, where we talk about less waste, less emissions, and energy efficiency, versus the eco-effectiveness, where we talk about no waste, no emissions, or even a positive footprint, which is a very important issue. I'll come back to it. And the beneficiality, or in terms of energy, the Exergy approach. This is an example from Norbert Fisch, German professor who built a home with a positive footprint in terms of energy. You see in the vertical axis the energy consumption per year, and you see, of course, the standard and the improved level of the passive house, but his home is generating sustainable energy, and after 10 years he has also earned back his embodied energy for the building itself. Comparable things can be done with water. Here you see a pharma filter installation at the hospital in Delft, where they produce the wastewater, the urine, etc., into a water quality which is near drinking water quality. We cannot call it drinking water quality, but it is basically the level that is needed. So better water out as in. So to understand the difference between efficiency and effectiveness is the efficiency is doing things right, where effectiveness is, of course, doing the right things. So this is an example of very efficient transport, and this is absolutely not effective. Now, the point of view is that there are different ways of approaching certain problems. So you can ask yourself whether these emissions are a problem or a chance, using the CO2 in algae facilities to produce biomass, etc. Or these palm oil plantages which produce large emissions of nutrients in biological contaminated water. Is it water treatment we need, or do we have to harvest the nutrients and have clean water as a byproduct? The question therefore is, are we doing the right things? And Michael Braunkart has a very good answer on it, as you can see here in a visual representation. Sorry. Or are we just doing things right? And we are basically very good at doing very bad things in a very efficient way. And I saw a very nice example in China, and I want to conclude with that. So thank you very much for your attention.